let's look at one last problem. This one's a little bit more complicated because we have two pieces that are more complicated. We have a 7k and let's see, a negative 9j, and it's raised to the fourth power. We still want to use the binomial theorem, so we still have to go piece by piece. So let's start out with the 7k. On the first piece should be raised to your highest exponent, the fourth. But then your negative 9j should be, we shouldn't have any of those, so it should be raised to 0. And let's see, we still have to do our combination that's out in front. The combination will be that our power is 4, and we'll start out with the lowest, the 0. Well, let's see. We've got the the 4 with the 0, which is going to give us just, that whole combination will just be 1. But we also have a 7 to the fourth here, whatever that is. And technically raised to 0, we have a negative 9 to the 0, but we already said anything raised to 0 is also just another 1. So we really just end up with the 7 to the fourth, which is 2,401. What also do we have is we have this k to the fourth power. We said that the j was to 0, so we don't end up with any j's yet. Next term, we take our 7k and now raise it to the third power. Okay, and we take our negative 9j, and we'd have one of these now to the first power, and we still have to find out what our combination is. We do just like before with our combination, we do our 4 on top and the 1 on the bottom, working our way up. Well, let's see. Our combination of 4 with the 1 on the bottom will just give us a 4. But then we have to multiply that by the 7 to the third power as well. And we also have a negative 9 to the first power. So we have a 4, a 7 cubed, and a negative 9 that are all getting multiplied together. And when you multiply the 4, the 7 cubed, and the negative 9, what you end up with is this huge number, a negative 12,348. Notice you also have the k to the third, and we do have, notice, a j to the first power, so just a j, 1j. That's our second term. We still have to do a couple more terms here. The next term takes our 7k and now does it, we're working our way down. We had third power, now we're going to do squared. And we're also going to work our way up on our negative 9j. It's going to be now squared because we just had 1. And we still have to do our combination of 4 on top and 2 on the bottom. First, our combination here, our 4 with the 2 on the bottom, will just get us the number 6. But it still has to get multiplied by the 7 squared here, which is 49. And it also has to get multiplied by a negative 9 squared. Be careful, a negative 9 squared is actually a positive 81. So I'm multiplying a 6 from the combination, a 7 squared because I was squaring the 7k, and a negative 9 squared here, which is 81. So a 6 times a 49 times an 81 gets me a very large number altogether. I'm getting 23,841. Again, remember I had 2 k's, a k squared, and I had 2 j's, a j squared. Second to last term, I have to take my 7k and raise it. Now I'm working my way down to just 1 copy of that. And my negative 9j is now going to be raised to the third power. And I have to do one of my last combos, which is a 4 and a 3. Well, the 4 and the 3 is just going to get me a 4 again. Let's see. Times, we also have a 7 to the first power, which is just 7. But I also have a negative 9 cubed. Be careful. A negative 9, now it's raised to the third power, is actually going to stay a negative number. So I've got negative 9 times negative 9 times negative 9 times a 7 and times a 4. Let's see what we get. So when I multiply those three negative 9s, a 7, and a 4, I get negative 20,412. Notice in this piece, though, I've got just one k, a k to the first power. But I've worked my way up with my j's, so I've got a j cubed or a j to the third power. Last piece. Our last piece is going to take our 7k and raise it to the 0. Well, remember, anything raised to 0 is just 1. That whole piece will just vanish. There's no k's and no 7s. But we will have a negative 9j to the 4th. Well, and I also have to do my combination of 4 and 4. Well, the combination of 4 and 4 will just give me that combination of 4 and 4 out in front will just give me a 1 times whatever your negative 9 to the 4th is. So the question becomes, what is 9 times 9 times 9? Again, it's negative, but because it's an even exponent, it will become a positive, which is why we see a positive here. Well, 9 to the 4th power is 6,561. Remember, the k's are vanished. We're working our way down with those, but up with the j's. So I have a j to the, let's see what it was. Working our way up, we have a j to the 4th power. So that's our last term. So we can see that this binomial theorem is pretty involved. The higher the exponent on our binomial, the more terms we end up with, and it's just messy.